Hey Kendra, I am happy to do examples 6 and 18 from the final review packet. So, starting with 6. Now we are given the universal set which contains all of the elements that would exist for this problem. And then you'll see a few subsets. Subset A is DEFGH, subset B is FGHIJ, and subset C is only a K. A says that we want the union of sets A and B. Now that would be all of the elements that are in either set A or B. Like throwing them all in a big bag. It just holds, or in a bucket, everything that you have. So when we look at the sets for everything, we're going to start with everything that is in set A. And then on top of that, we're going to look at everything that is in B. And then we're going to add to it. Now, I see that F is in B, but F is already written in the set. G is in B, it's already written in the set. H is in B, it's already written in the set. But then I look at I and J. Now, those are not yet written in the set, so I'll add them. And that would be the union of sets, or A union B, or the union of sets A and B. Now, for B, it's B intersect C. And it would be everything that they have in common, or only the things that they have in common. Now, if you look at the sets B and C, they have nothing in common. Because they have nothing in common, our answer would be the empty set. Now, C is the complement of A union B. The complement, which is that line across the top, means that it is everything in the union that is everything that is in the universal set that is not in A union B. All right, so anything that we have listed, D, E, F, G, H, I, J, we are not going to put those in the set. So I'm actually just going to cancel it out of the universal set. What is left would be A, B, C, and a K. That is what would be in the complement of A union B. Now D. A union B, now that's in parentheses, and you'll notice that that is equal to what we found in part A of this question. And we want to intersect it with the complement of C. Now, the complement of C is everything that is in the universal set that is not in C. So if we were just to look at the complement of C, it would be everything but K, since K is the only element that is in C. Okay, so that would, what I wrote is what C complement would look like. Now we want to do the intersection of A union B and C complement. And when we look at the intersection, it is what they would have in common. It is going to be the set of D, E, F, G, H, I. Oh, and I forgot one here. And a J. Or A union B is really what it would be equal to. So that is how we would do number 6, A through D. Now on to number 18. For number 18, we are asked to find the first 5 terms of the sequence described as a sub n equals n squared minus 1 for n greater than or equal to 0. Now it's telling us that n can start at 0. So for when the first term is when n is equal to 0, a sub 0 is 0 squared minus 1, or a minus 1. That's the first term. The second term is when n is equal to 1. A sub 1 is 1 squared minus 1, or 0. That is the second term. N equal to 2 would be our third, will help us find our third value. A sub 2 is 2 squared minus 1, or 3. To find our fourth term, well, we're just going to increase n by 1. We have n is equal to 3. A sub 3 is 3 squared minus 1, or 8. And finally, our fifth term occurs when n is equal to 4. 4 squared minus 1 is equal to 15. So to list these out very nice, my terms are 0 or -1, 0, 3, 8, and 15. The first 5 terms of my sequence.